Here we go. We are recording. This is the third installment. Okay. So here's what we got. Let's where'd Jade go? Jade's
I'm
gone.
here.
Oh,
She's here.
there she is.
I'm here.
Oh, okay. All right. So let's see. So like say like Jade, can you walk through that function again for us? Like line 33 and just recap of like what exactly it's doing.
Okay. Then I have some questions. So basically,
Sure.
we have this let largest here. That's an empty array. And what we were originally doing is you do a for loop to check for the primes again on num.
Mhm.
And then if the number is divided by I and it has a remainder of 0, then
Mhm.
we're pushing all of those numbers into largest right now.
Okay.
And then the next line is this, I guess, where I'm kind of having questions about
Sure.
checking factors to see if they're prime.
Yep.
This is kind of where I'm a little bit confused.
Sure. Okay. So can anybody attempt to explain that, Desiree or Tani?
Well, I'm kind of lost now, so I don't know how much
Okay.
help I could be.
Sorry.
Well-
So go ahead. Tani, go ahead.
Oh, no, I'm reading it. Sorry.
Okay. I was going to say, like, this is where inside of Palia's problem solving like method, this is where you get to like, you go understanding the problem, devising a plan, implementing the plan. Now you're like, what the heck is going on? This is where you go back to understanding the problem, right? And then you, from there, then you just move back forward. So maybe like we look at the plan and we just see if, are we translating everything correctly? Because like Desiree was saying today, like, the issue is like you can know what you want to do, but if you can't, like translating it shouldn't be the hard part. Like writing the plan should be the hard part. Translating it, I mean, like if you know the syntax, you could just translate it. It's a matter of just like knowing the steps you want. And so the steps have changed like a lot since we started, right?
Yeah.
We've changed a lot. So like we're all muddled and confused. So why not like go back to those steps right up top real quick and just maybe define some general ideas of what we're trying to do. Yeah, 13 through 19 there.
Okay, so on number 1, we only have largest now.
Yep, so we can get rid of test, right?
Yeah.
Good. Okay. Number 2.
Looping through a range of numbers, which we kind of have set up. And that's just finding all the primes, right?
Right. Can we be more specific than just a range of numbers? What can we say about those numbers we're iterating
Between
through?
0 and the whatever
Very-
number we pass in.
No.
Yes. Yes. So let's put that in there on line 2.
It should actually be between 1 and the number, because 0, we shouldn't divide by 0 to give us like
Right.
imaginary number or something like that.
Right. And if we're gonna go even more specific, then we don't have to put 1 because like 2 is the actual first prime factor. Here we go. Okay. So then what are we doing after we loop through those numbers? So we're basically finding like the factors first, right?
Mhm.
And then from the factors list, we're trying to say, okay, which one of these
Is
like
the largest.
Yeah. Well, we're actually
Sorry,
not,
I just
doing the
wanna
list.
interject
Sorry.
really quickly, because we're looping through a range of numbers. The reason why we're looping between 1 and the number is because that first loop is to find the factors, and so 1 is a factor of everything. So we don't want to leave that out.
Well, okay.
Well, at least I don't think we should leave it out.
You're essentially right, but it like in the same way that you excluded 0 because you said that you don't want 0 to be like it's never going to be a factor anyways, right? 1 is never going to be a prime factor to begin with because 1 is not a prime number. So that's why I decided to exclude it, because you're essentially going to iterate through every single number all the way up to the number that you pass in, right? So like if you pass in, we're passing in, what's the number we're passing in? Like some, okay, say we pass in like 100, right? Like 1, 2, 3, 4, 5. Those are all possible factors. And then what we're doing is we're finding whether or not that number is a factor, which later we'll go even deeper and find out whether that factor is a prime number. And that's how we'll find the prime factor. So like, that's why I said we might as well just exclude the 1 then, because we know that 1 is not a prime number.
2 is
Right.
going to be the lowest possible.
2 is going to be the lowest prime number. So that's what I meant, Desiree, by excluding that one. But I understand your logic there. It was like in the same way that we're like excluding 0 because we know it's never going to be a factor. We know that 1 is never going to be a prime number. Does that make sense, Des?
I guess I've just always thought that 1 was a prime number.
No, so that goes back to step 1, understanding the problem. Is like, I didn't know it wasn't a prime number either. So actually, if you go in and look it up, like 1 is actually not a prime number. I only know that because I did this problem a while back, and otherwise I would have said the same thing.
Yeah, it's not, because it's only divisible by itself, right? It has to be divisible by 2 things, itself and 1. But since it is 1, it's only divisible by 1 thing. So,
Okay, so
let's see, prime number.
so maybe that actually goes under understanding, and then you can put like a subcategory underneath there that says constraints, and then you could say like 1 is not a prime number or something, or that would work there too. That's fine there too. That's good. And then another thing that we have to account for, which we haven't, is can our function take in negative numbers? Like basically you want to try to break your own function that you're creating, right? Because what happened if it did take in a negative number? What would happen? We'd want to account for that.
Well, we said greater than, right? So yeah, we'd have to.
Oh yeah, okay. Or like a float. If it took in a float or like a string or something, we'd have to make sure that we account for those too. But let's keep going. All right, so we're at where are we at? We're loop through the range of numbers between 2 and the num passed in. And maybe we can put in there maybe parentheses after number 2 and put like a list of possible like factors, right? Because that's essentially what we're iterating through, right? A list of possible factors. And then from those numbers that we like deduce is a factor, we try to tell is this like a prime number? Because we know it's a factor, but we need to figure out, is it a prime number? So like we're getting more and more specific with it every time.
Oh, I see. So down here, then I would say loop through instead of
Well, actually, we shouldn't have to.
This is a different.
Yeah. You're right.
I literally
right.
just transposed whatever.
No, you're right. You're right. That's right, though. Yep. So you can delete that, and we could put a different number 3 in there.
Yeah.
Okay. So Des,
anything was relevant.
Yeah. So Des, we have like, let's say we're ranging through, right? And we get to like 5. We know 5 is like a factor of 100. Like say we're passing on 100. We know 5 is a factor. We're at the iteration right now. Like what's the next thing you're gonna do with that number to get even more specific? Like how do we determine if that number is a prime number?
We're gonna check to see if it's divisible between 1 and itself.
Yes. And then how would you keep track of, like, so while you're iterating through all of the numbers between 1 and the factor, right? Like how do you keep track of, because we said in our understanding phase, we said it can only be divisible by 1 and itself. So that means that all prime numbers have how many factors?
2.
At least 2.
2. All prime numbers have only 2, right? You can't have.
They have exactly 2.
F exactly 2, right? And so how would we create a conditional that would filter for that? Or how do we, what will we do to make sure that that we get that we know like the number of divisors, I guess, that there are in a number? What about like a counter variable? Can you create like a factors counter variable inside that second for loop we're about to run? Does that make sense, guys?
Yeah.
Yes. So we would call it like divisors and do iteration, like a plus type deal.
Well, actually, I was thinking like you already have like a for loop, that second for
Mhm.
loop on line 35, right? Because the first for loop is let's find a factor. And once you found that one, you got it like right here in your hand. You're saying, okay, let's iterate with all the numbers between 1 and this number and see like how many factors there are. If there are more than 2 factors, we know it's not prime. If it goes through the whole, like it goes to that whole range, and like the counter variable we have, it goes higher than 2, we know we can just get rid of it. We know we could just like discard it, right? Because it's not a prime number then at that point. And then we just go to the next one. Does that make sense? I got it. Here we go. Here we go. Hold on. I got my trusty
I'm just
whiteboard
getting
here.
tired personally.
Oh, okay, no problem. Yeah,
That's my.
I don't want to. You guys don't have to stay that long. I just I'll give the answer after this.
Oh, sorry, that wasn't not a
Oh,
on
sorry.
you. I was just saying I'm just tired. I wasn't
Me
trying.
too. You're good. You're good. You're good. All right. Okay.
I'll stop sharing so that
Oh, okay. No problem.
so everyone can see the board.
Thank you. Okay. You guys see that? Okay.
Yeah, we
Okay.
can see it.
Okay. So the first for loop, right? Let's say our example is. Give me an example. 10. Okay. So Marcus. Okay. So we have a function, right? Let's call it find. I'm gonna call F L largest prime factor PF. I'm just call it LPF, largest prime factor. Okay, it's gonna take in one parameter, we'll call it num, and there's our curly brackets. Okay, so the first, we have like a largest variable, right?
Yeah.
So let largest, and we'll just set it equal to 0, right? Because we know that this is gonna be better than doing an array where we have to constantly push it in every time. And so anytime we find a really large one, we just pop it in there. Next, we have a for loop. And can you guys remind me what the constraints are for this? We're going to start at 2, right?
Let I equal 2.
Okay. Let I equal 2. Okay. And I is less than num, right?
Yes.
Okay. And we're going to keep going up. Okay. All right. So this first for loop is doing what?
It's looking for the factor. Or wait.
Yeah. Yes.
Yes.
Yes. Yes. Okay. So after we find a factor, right? We say if I modulo 2, right? Is or sorry, modulo I. I'm sorry.
Yeah.
Num modulo I.
There's no I.
Yeah.
I'm sorry. Yeah.
No,
Num
it's okay.
modulo I. Num modulo I is equal to 0. Then we know it's a factor,
Yes.
right? Okay. So we take that number and now we need to figure out if it's a prime number. So what are the qualifications for prime again?
It has to be divisible by 1 in itself.
1 in itself. So that's how many total factors would a prime number have?
2.
Exactly 2.
Okay, perfect. So we can create a conditional here that says if, we actually have to declare a counter variable, right? So let's do this, do a let factors counter equal 0, right? And then right under there, we can do our for loop. So another for loop. And here we'll use J. And then what are we going to start at? Will we start at 0, 1, or 2, Des? For the second for loop. For the second for loop, remember we're trying to find the all the factors of that number, right? So here we're trying to like define the factors of num, and then for the other for loop, we're trying to find all the factors of that factor, basically, right? Does that make sense? Okay.
Are we trying to exclude it or are we trying to include it now? So are we trying to say, it kind of depends on which direction we're going. Like, are we saying if it is, if it has more than 2, then it's not a prime number, or if it's equal to 2, then it is a prime? Like, where are we going with our sentence?
We want to be able to iterate through all the numbers between, so we should really start at 1, right? Because 0 is not going to be a factor of any number. So we'll start at
1.
Yeah.
Start at 1. Good. Okay. And then what's my constraint in here? My conditional? Where J is what? So for let J equal 1, where J is, and this is pertaining to exactly what you said, Tani. Is J ever going to be, like, can a number be divisible by itself?
Yes.
Yes.
Yes. So we want exclusive or inclusive for J?
Inclusive?
Correct. So we'll say it's less than or equal to
Could
I,
you
right?
push your board down a little?
We're getting a
The
little bit of
bottom,
the,
just the bottom.
we're
getting a
glare off
reflection.
if you just angle it. Oh, that's perfect. No,
Yeah,
that's
perfect.
perfect right there.
Awesome.
Better right
Awesome.
there? Right
That's
there?
good too. Yeah.
All right. Okay. Okay, so
Thank you.
no problem. Where J is less than or equal to I, right? Because I is that's the number we're looking at from here. Okay. And lastly, we'll just keep increasing. Okay, that looks sketchy. Okay. So if a number does make it through here, what if statement can we use right here that will let us know when to break out? Actually, no. How do we factor in this this variable we created here inside the original for loop, factors counter?
If factors counter is, do we want it to include it? Do we want to say it's equal to 2, or do we want to say it's? I'm having a hard time thinking.
Well, so if we're gonna like loop through the numbers, right? Let's create examples. That's the best way to see, right? You got 1, 2, 3, 4, and 5. Give me all the factors. Give me all the factors of 5 here.
It's just
1 and 5.
1 and 5, yeah.
1 and 5, right?
Yeah.
As you're looping through like this though, if you stop at 2 and then there's another factor at the end, right? Like, will we miss out on that? And we'll miscorrect, or we will diagnose a non-prime number or a prime number before we even get to the end. So we have to make it. So we have to make it all the way to the end, right?
Mm-hmm.
So yeah, we have to say here, if it is if factors counter is what? Factors counter
is equal
think back to like qualifications for a prime number. And actually, you know what? We may not even want that there. Since we wanted to go through every iteration, would it make more sense to put it on the outside of the for loop or at the end of the for loop? So potentially it could fall between this curly brace and this curly brace. So right in between here, right? Right, so you're going through there. At this point here, this is in between. So this would be if factors counter is equal to or is greater than 2, right?
Mm-hmm.
Because that means that we'll have already finished the loop, right? Because we want to finish that whole loop before we check what whether or not factors counter is greater than 2. If we put this inside the loop, it can prematurely tell us that a number is prime when it's really not, right? So this is going to be kind of tough here. That's really hard. Okay. You'll just, okay, well, when we put it in the code, it'll look better than this. I'm sorry. Okay. So if factors counter is greater than 2, what are we going to do with this?
Ignore it.
Ignore it, right? And then
Move
else.
on to the next one.
So I'll put an else statement here. So we could just put continue, right? Or break.
Next.
Yeah. Next. Yeah, I'm not
We
even
don't
sure.
know if that works or not.
Yeah.
We haven't decided.
Okay, so, but what if it isn't greater than 2?
If it isn't greater than 2, don't we want to put it as largest?
Yeah. So we have the else statement here. So we're going to set largest equal
Equals
to
factors
Which one?
counter?
factors counter.
Or, no, wait.
Factors counter would just tell us what? How many factors are in the
And,
factor, right?
yeah. So are we setting it to I, going back to the top loop?
Yeah. Yep.
Yeah.
Because that's the original value we're looking at, right? So we'll
Mhm.
set largest to I, like that. And then basically we'll continue running through that whole thing until you've gone through every single number between 2 and exclusive the number that we're passing through, right? Or actually, do we want that to be exclusive or do we want it to be inclusive? Because a factor, like the number itself, is that a factor or not? Can it not
is
be
a factor.
Right. So should we make that
It should be also equal to.
inclusive? Good call. Okay. So does that make sense for everybody? What are we putting in right here? We could just print something.
Can we just print J just to see what it does, or?
Yeah.
At what point are you setting the factor counter?
We're setting it outside of the second for loop, because if we put it on the inside, it'll erase that number every time, right? We want it to memorize it. So you can either put it here or, yeah, we actually need to put it here. We can't put it out. There's no need to put it out there. We need to make it outside this for loop though.
So what I mean is, when is that incrementing?
Factors counter.
Is it going to be?
That's yeah. Yeah, there it is.
Would it be factors counter equals J? Is that to increment or no? Am I thinking of it wrong?
I think you just have to add 1 to factors counter.
Just counter?
Yep. Okay, so let's see. So we'll say, so actually we need to have the if statement here, right? To determine whether or not J is a factor, right? So are we gonna need to do, we need to do modulo again, right? Right?
Yeah, so we would do if J
Mm-hmm.
What would we set that to? Modulo.
Same thing, right?
It could be just the same I again?
We just divide by
Or
2, right?
2?
Divide
Oh,
by 2.
okay.
Okay. So in between here, so if we know that, then we're going to do what Des said, and we're going to increase the factors counter by 1, right? If it does end up being, if 0
Why are
ends
we
up being the
dividing
remainder.
by 2?
When you do j modulo 2 equals 0,
Uh-huh.
that means you're checking to see if it's even.
Correct.
Right.
Correct. Because
Wait, why?
now we're checking. So the first for loop, we're checking for the factors of num, right? Once we finally get a factor, we're like coming down deeper and we're saying, okay, is the factor that we found, like, is that a prime number? And how do we check for a prime number? We need to make sure that we're going to iterate from 1 all the way to the number itself, which is I. And then like, so that could be like, let's say 10, right? We're finding all the factors of 10. We start with like
2,
1,
5.
2, 3, 4. Yep, we'll go all the way up, right? 5. We get to 5, right? All of a sudden we're like, okay, 5 is a factor of 10. So we bring it down to this stage right here, right? And now we're saying, okay, we need to figure out like if this number here has like only 2 factors, right? So what do? We do 1, 2, 3, 4, 5s, right? So we only go up to the number here, right? And so what we do is anytime we find a factor, we're incrementing a variable over here. So like we go 1, okay, so we're gonna increment that. So now it's 1. Okay, so 2 is 2. No, it's not. Is 3 a factor of 5? No, it's not. 4? No. 5 is. So add another one. So now we have 2, right? And that's when factor counter increases. And then when we exit this for loop right here, the second one, we come down here and we evaluate, is factors counter greater than 2? If it isn't, you know that's a prime number.
Okay, so
Right.
why are we checking if it's even?
Yeah, I don't quite get it.
So how else would you check a factor? So
Needs to
yeah.
know if the number that we're dividing it by is equal to 0. So right now we're dividing everything by 2.
Right, because that's how you figure out if a number it like divides into another number, right? Evenly,
No. Oh.
right?
So that's
Am I right?
that's to check if a number is actually even. Like if j equals 2, then it'll have a remainder of 0 with modulo 2 because it's even. If j equals 4, then it would have a remainder of 0.
Oh,
Right.
Yeah, it
okay. I see what you're
literally
saying.
just checks.
So okay, so good catch. So then this should be I. So this should be I divided by, sorry, j divided by. No, actually 5. 5 divided by I, right? Yeah. So it should be I divided by j. Good call. Good catch. So I modulo j, right? Because then we're checking here. So is 5 divisible by 1, which is the first j? Is 5 divisible by 2, which is the second j? 5 divisible by 3, which is the third j, and so forth. And we only get that these are the only divisible j's, right? From I, which would be 1 in itself. 5, 1 in itself. So then we know that is that this number 5 only has 2 factors, right? So then factors counter would only increase to like 2. So then it wouldn't hit this right here. And then we know that down here, we're changing largest to the value of I because we know it's a prime number. Boom.
So inside that if statement, then we need to increase factors counter by 1 each time.
Yes, right here. Good call. Factors counter plus. Yes, and we have 10 minutes left. So let's run that code and let's get this answer and get you guys out of here. All right, I'll keep this here so you guys can see. Sorry,
Okay.
it's messy.
So I'll just write it out then.
Okay. Yeah. Can somebody, maybe
Just
somebody
'cause
can
you-
walk?
Yeah, if I share, then they won't see your screen.
Oh, okay.
Okay, so it's
Um,
function LPF, passing in num as an argument,
The
Let
I is less than or equal to.
equals 0. Let me know if I'm going too fast.
well, actually, here, you want me to do this? I'll take.
If he just
I'll-
has,
Yeah, I'll take a picture of it, and then
Yeah.
I'll let you share your screen, okay? And then you guys can
that's good.
read from there. That's a little bit easier to navigate.
Is there a less than or equal to shortcut?
Sorry. Let me take a screenshot here.
It's the less than sign.
It's oh I know. Yeah, thank you. I don't know where I was having like one of those moments.
Okay, got it. That is some really good team problem solving right there. And it's really good because I had like the accountability. Like Des was like, yo, Teak, what you doing, Teak? Hold on, Teak. That ain't right, Teak. I'm like, okay, then, okay. Let's see. Let me drop this in the channel.
Bless you.
Okay. So maybe Des or Jade can do a play-by-play for Tani. That is so
Or I
messy.
can also do
Oh, right.
screen share both.
Got you. So that problem
If you
by
want.
myself took me about like 2 days to solve by myself. So like you guys are already doing way better than I was.
Oh no, it's backwards.
Oh, sorry.
Got you. So it's function LPF.
She's like, I got you. Oh, I don't know why.
That's too good. All
Come
right.
on, T.
So that's okay.
Why are you doing the
So
mirror image
that-
out here, T?
No, this is fun. So it's a nice challenge.
Okay, so we
Let
named
counterfactor.
largest prime factor. Num let largest equal 0. We have that. For let I equal to I greater than or equal to num. Yeah, you have that. If num modulo I equals 0, you got that. Let function count or factor counter equals 0, you got that. And then okay, so that's going to be a 4
Where I'm having a hard time reading it backwards. Oh wait, is this
on 34.
thing?
There we go. I just dropped in the channel with my phone.
Okay, that'll be good.
There you go. Sorry about that. I'll delete
No, it's okay. It was exciting. Okay.
that.
So you can delete the if.
Well, this is later, right?
Yeah.
Okay.
So for let j equals 1, greater than or less than or equal to I, j plus plus.
Oops. There's two inside of that. Hang on, buddy. What do you say next, maybe? Or can I leave it empty?
I don't know how that works.
You're on mute.
I'm sorry. You could just print something if you want. Tani, you could just like print like not a, like an F string or whatever. Like put an F string like not, like J is not a, or yeah, I is not a prime number or
Is it
prime factor.
prime?
Prime
Yeah.
factor. Not a prime factor. There you go. And you could pass in
You'd have to do string interpolation
Yeah. Yep.
to do those backticks.
hmm
And then
Very nice.
brackets, yep. Do you have to do a $sign before it?
Yeah. Yep. Dollar
Oh,
sign
yeah.
before the
Jeez.
curly brackets. There you go. It's all right.
I
It's good
can't remember
practice.
anything tonight.
This is how you get that practice right here. There you go.
Then we'll get rid of that.
Return markers.
So we need to return this.
Yes.
There. There.
Mhm.
All right.
Right. So we
So
get
can
rid
I
of that
just-
check prime.
Yep.
Oh,
Yep,
yeah,
we're
we don't
just-
have that
we're
anymore.
just calling. Let's pass in a number that we know the answer to.
So this is the one.
Okay,
the
yep. So
example.
29. Okay, so 29 is gonna be the largest one, right?
Should
Yeah.
be.
All
Uh-oh.
right, what do we got?
Um,
Wait, what?
5, 3, 7, 5, 15, 85.
What is going on? That's
Up,
like
up, up.
split.
Run it again so it can
yeah.
clear that out nicely.
Yeah,
Okay, that was
there you
weird.
go.
J is not defined. J.
What line is that saying? Line
Because
24?
J is in the for
40?
loop, and we're
Um,
trying to pull it out in the if.
Oh, yeah.
Gotcha.
Yeah.
okay.
Okay.
Say it's not a prime number, a factor.
Yeah,
Just make
yeah,
it
that's
simple.
fine. Yeah. There you go.
Oh, wow. Not is not.
Mm-hmm.
Got it.
There we go. Good work, y'alls.
So
So then we can
let's
put in
put
the
the
bigger
real
number.
number.
Yeah.
Mm-hmm. Yeah. And I'll tell you if it's right or not. So this is where, so you're like seeing in real time, like how it's, calculating it. Like this is where you can optimize, and it would not take this long. It would just be like, boom. But I was
in less than a minute.
focusing on the brute force solution.
Which is better for our understanding, I'm sure.
Well, yeah, brute force. You always, even in an interview, you want to talk about the brute force solution first, even if you're not going to use it, to show that you know how to improve upon solutions. So I actually use a dictionary in mine instead of nested for loops, and that allows you to when you take a for loop outside of another for loop, it like significantly increases the optimization of it. It's so much faster.
You solved it in Python?
JavaScript.
Oh, can you or it's like an object?
Object, yeah.
Yeah. So yeah, we'd be yeah.
So
Object.
Come on,
technically, we
laptop.
could have taken this for loop and applied it
Mhm.
to the solution we had earlier, where we were pushing it
Yeah.
into an array.
Okay.
Yes. Yep. Because then it would separate. It would pull the for loop out, and then you wouldn't have to.
Sit
Yeah.
through this.
Yeah.
I feel like the Zoom's gonna cut out before we finish.
Okay.
Possibly. I could just let it run and you could drop it and I'll let you know.
It's gonna be a while. I think it was like, I don't know. I went in the shower and came back, and it still wasn't done. But
Hey, I believe it.
I'll drop my solution
Okay.
and the answer for you guys. Okay.
Okay.
All right. Should I drop this at all or no? It's the same.
You can
I
just
mean,
leave
it's
it in
in
there. You
our
can just,
yeah.
yeah. Actually, it is a solution. I'll just provide another solution.